Hello guys, how are you? Okay, so welcome to today's Brainiacs Capsule. So we will be continuing our second session on ozonolysis. It's a very important topic from chapter hydrocarbons. Okay, so here I hope you could see the question. The question here is the ozonolysis of an olefin. Okay, it gives propanone as the product. Which is that olefin? Olefin is the another name for alkene actually. So you are given four different options of alkene. You need to identify which of these following alkene will give you propanone on ozonolysis. Okay. So let's see what is propanone actually. So propanone is this particular compound. You can see here CH3, okay, C double bond O CH3. Okay, you have three carbons and there is a carbonyl group and this is a ketone, propanone, or nothing but our dimethyl ketone or acetone. Okay, now we need to identify that. So what we will do, the easiest way is, there are multiple ways you can attend this question, but I will tell you the shortcut at the last. Okay, the normal method is we will take each option and do the ozonolysis. Okay, let's see that one by one. So the first option you can see here, I have taken butene for you. Okay, so the first option I have taken butene. So you know this is but1ene. And how to do ozonolysis, sir? I have told you the shortcut, very simple. What you need to do, remove the double bond or break the double bond completely and distribute oxygen on both sides. So when you are distributing oxygen on both sides, this will become CH3, CH2, CHO, and this will become HCHO. So I can say the compound you are getting here is CH3, CH2, CHO. That is an aldehyde. This is an aldehyde. But what we need is a ketone. And HCHO, this is also formaldehyde, which is another aldehyde. Okay. Next we will try with but2ene. So but2ene means the position of the double bond will come here. Again, the method remains the same. Break the double bond completely and distribute oxygen on both sides. Okay, so what you will get again, so here also you are getting CH3CHO, and here also CH3CHO. So both of them are what? Aldehydes. Okay, but we are expecting a ketone as the product. Okay, so we'll go to the third option. Now you can see when you are reading the third option, it is 2,3 dimethyl butadiene. That means at the second and third position you have a substitution as a methyl. Now you can think logically, this should be present as a branching. Why? Because this needs to be a ketone, means to the carbon there should be two other carbon atoms connected, then only it can become a ketone. So with this particular logic, I don't want to even do this question. I can simply select the option C. Why? Because in this option only you can see branching is present. If there is a branching at the double bonded carbon, then only this will become a ketone. Why? Because it needs to be a ketone, means the carbon should be connected to two other carbon atoms. This is my this is my trick actually. Okay, so with this you can easily get the answer. So if you do the ozonolysis normally also, you will get the answer. You break the double bond, distribute oxygen on both sides. So you can see here CH3 CO CH3. Correct. So I can easily say you will get propanone from here. Correct. So very simple. You don't need to even try the fourth option, but you can just check, that is propene. So propene, if you are doing ozonolysis, you can see here oxygen coming here, oxygen coming here. So CH3CHO, that is you can see ethanol, and HCHO, that is nothing but our formaldehyde. Okay. So tell me the answer. Now you know, without even doing it, you can get the answer. What is the answer? Option 3 is the correct answer. I hope you understood the logic as well as the important way we need to attend this trick. Okay, clear. Now let's go to the next question. Okay, so I hope this question is clear for you. This is also a question from ozonolysis. Please, all of you, read the question first. Okay, so the question here is, on ozonolysis, one molecule of a hydrocarbon produces two molecules of ethanol. So they are telling two molecules of aldehyde are produced, ethanol, and a one molecule of ethane diol. So what is ethanol first? I will write for you. Ethanol is CH3 CHO. This is ethanol. Why ethanol? Because there are two carbon atoms and an aldehyde. So this is ethanol. And what is ethane diol? Ethane diol. That's what they are telling. So ethane diol means, you can see here. 1 minute. Let me. Yeah. So ethane diol is nothing but this one. our glyoxal CHO single bond CHO. Why it is called ethane dial? Because there are two carbon atoms, so we say eth. They are connected through single bond, so we say ethane, single bonded ethane, and you have two times aldehyde, so that is why we say ethane dial. Okay, or the another name of this compound is glyoxal, because this is one product we are getting whenever we do ozonolysis of which compound, sir? Can you tell me? Benzene. Please remember on glyoxal. So if you do take benzene and perform ozonolysis, you will get 3 molecules of this one. Okay, so let's try it out actually. So here you have different options. 1,3-hexadiene. First one we will take 1,3-hexadiene. So you can see here this is 1,3-hexadiene. So 1, 2, 3, 4, 5, 6. So this is 1,3-hexadiene. Okay, so how to perform ozonolysis of a diene? Very simple. Again, the concept remains the same. Break the double bond or remove the double bond completely. Distribute oxygen on both sides. Similarly, remove the double bond. Put oxygen on both sides. Now you will get fundamentally this as one compound, that is HCHO, and other one will be this compound. You have broken here. So you can see here this is glyoxal you are getting, or ethane dial. And here but you are getting what actually? You can see CH3, CH2, CHO. That is, we can say propanol. But in the question they are telling you will get 2 molecules. They are clearly telling how much, sir? You can see here 2 molecules of ethanol and 1 molecule of ethane dial. So there is no 2 molecules of ethanol is not there. So we will try the next one. That is 1,4-cyclohexadiene. So cyclohexane is this one. Hexadiene 1,4. That means you can number it 1. You cannot number it like this. That is wrong. Because whenever double bond is there, continuously you need to number it. 1, 2, 3, 4, 5, 6. So you are numbering. So 1 is the minimum number between 1 and 2. And 4 and 5, 4 is the minimum number. So we can say 1,4-cyclohexa. Why hexa? Because 6 carbon atoms are there. Diene, 2 double bonds are there. Now you do the ozonolysis. Well, how? You perform complete breakage of this double bond and put oxygen on both sides. So this one will completely become one part. That means here you have carbon, carbon, carbon. So a 3 carbon compound you will get. You can see here CHO, CH2, CHO. The second half is also symmetrical. So CHO, CH2, CHO. You will get the same, but it has no relation with our compound what we needed actually. So next we will see 1,4-hexadiene. 1,4 means you can see here 1, 2, 3, 4, 5, 6. This is 1,4-hexadiene. Again you do ozonolysis. You can break the bond, completely remove the double bond and put oxygen on both sides. Here also completely remove the double bond and put oxygen on both sides. So what you will get here, this thing, it will become HCHO. This will become CHO, CH2, CHO. This will become CHO, CH2, CHO. You can see here. Correct? Now the last one again you can see CH3, CHO it is becoming. Correct? So you are getting again a different compound. We need glyoxal and 2 molecules of ethanol, but we are not getting until now. So we are going to option D, that is 2,4-hexadiene. That is 1, 2, 3, 4, 5, 6. This is 2,4-hexadiene. Now we are doing the ozonolysis. You can easily see that here also I am removing the double bond and putting oxygen on both sides. Here also I am removing the double bond and putting oxygen on both sides. So this is becoming ethanol, CH3CHO, correct? And this is becoming glyoxal, CHO, single bond, CHO. So this is becoming glyoxal. And the last one is also becoming ethanol. So that means you are getting 2 molecules of ethanol and 1 molecule of glyoxal or ethane 1,2-dial. Clear? So my answer would be option D would be my correct answer. Clear? So I hope you know how to do this question clearly. Yes. Super. Now let's go to the last question for the day. Okay. So the last question we have. So the question is here for you. I hope you could see. Okay. The question here is 1 mole of a symmetrical alkene. Please remember the term symmetrical. So this is a clue. On ozonolysis, it gives 2 moles of an aldehyde having a molecular mass of 58U. The alkene is. Now they have given different options. Pentene, we know pent-1-ene, it is not a symmetrical compound. Then we have hex-2-ene. In hex-2-ene is not symmetrical. Hex-1-ene is also not symmetrical. Hex-3-ene is symmetrical in nature. So I can say from this itself, option 3 would be the correct answer. You don't need to do it also. Let's see again, doing it is always very simple. So as I told, hex-3-ene is a symmetrical alkene. Why it is symmetrical? Because if you break it from the middle, you are getting equal half on both sides. Okay, now you do the ozonolysis, you remove the double bond completely and distribute oxygen on both sides. So what you are getting, easily you can see propanol is what you are getting actually, because there are 3 carbon atoms present. So here also 3 carbon atoms. So I can say 2 moles of propanol is what you are getting. Correct? It's an aldehyde. And if you just maybe for verification, it's not actually required, but for verification you can calculate the mass. This is 12. Like that 3 carbon atoms are present, so I am making it as 12 into 3. Then you have totally 3 plus 2 plus 1 6 hydrogen atoms, so 6 into 1, and 1 oxygen atom 16, and if you add it you are getting 58. So that means this is my correct answer. Correct? Yeah. So I am not trying out the other options because you know how to do ozonolysis. So my answer here is, can you tell me? Sure. Okay, the answer is option 3 is my correct answer. Okay, I hope you have enjoyed today's session on ozonolysis and you get it completely cleared, I hope. Okay, please see also the other videos on ozonolysis that you can go to our playlist. You can find numerous videos on most important topics for NEET 2024. Okay, and feel free to put your comment on the comment box, and if you feel the lectures are worth, you can consider subscribing the channel. Thank you.